So, going back to an AND gate, right. Suppose we have A, B and C. The single structured fault model for this example will be A0, A1, B0, B1, C0, C1. So, there are 6 faults, 6 single structured faults. Let us see, if somebody gave me an AND gate and challenged me that A may be stuck at 0. Okay. So, how do I go to that person and say no, actually A may not be stuck at 0. Okay. So, this is a good circuit, this is a faulty circuit. If the faulty circuit had A equal to 0, then out will be C will be equal to 1. So, if I put how to disprove that person, some person comes and claims that I think A is stuck at 0. You have to say that no, it is not stuck at 0. What will convince him is if you can put a 0 on this somehow. If you can make C become equal to 0 and with the help of a measuring device, if you can tell me that look, C is actually 0, okay, it is not going to get stuck at 1. So, as a result, there is A is not stuck at 0. If A is stuck at 0, output would have been stuck at 1, but look, I am showing you that output is not stuck at 1. So, what will cause this to become 0? 1 1. So, apply 1 1, measure output. If it is 0, A0 does not exist. So, 1 1, okay, A equal to 1, B equal to 1 is a test for A stuck at 0. So, what is a test? A test is nothing but the inputs that you apply to the values that you apply to the inputs of the circuit, right, such that it activates the fault, okay, and it makes sure that the good circuit and the faulty circuit produce opposite values. Okay. So, when we apply a test, for A0, the response of good circuit and response of faulty circuit will be different. So, you can take this example. See, if I apply 1 1, a good circuit will produce a 0. If I apply the same value 1 1 and if this guy is stuck at 0, right, this 0 is going to cause a 1 to appear here. So, this 0 and this 1 are different. Okay. Therefore, 1 1 is a test vector for A 0. Similarly, let us take this is let us say stuck at 1, this is stuck at 1. this is B. If this is stuck at B 1, what will happen to the output? The output will act as B bar, isn't it? If this is 1 and this is B, the output will act as B bar. It should act as A B bar, but A is 1, therefore it is acting as B bar. A good circuit, this is a bad circuit. A good circuit will produce AB bar. So, we must find a value of AB such that B bar is different from AB bar. So, what will cause that to happen, right? Try A equal to 0, B equal to 0, then B bar will be 1 and AB bar will also be 1. So, this will not work. Try 0, 1, B bar will be 0 and AB bar will be 1. So, this will work. So, if you make A equal to 0 and B equal to 1, it will be a test. If you put 1 0, B bar is 1, AB bar is also 1. So, this will not work. Finally, we have 1 1. So, B bar will be 0 and AB whole bar, right, is also 0. So, this will also not work. So, the only test that will work is A is 0, B is 1. So, AB equal to 0 1 is a test for A stuck at 1. Is that clear? Now, let us consider the remaining two cases. Okay. By symmetry, okay, so the faults that we are looking at are A0, B0, A1, B1, then C0, C1. We argued that A0 for A0 we have to apply 1 1, a good circuit will produce a 0, okay, a bad circuit will good test output, faulty test output. For B0 by symmetry it is the same one, because there is no, so here also a good circuit will produce a 0. For A1 we argued that it is 0 1, a good circuit will produce a 1, a faulty circuit will produce a 0. By symmetry you can say B1 is 1 0. So, here it will be a good circuit will produce a 1, a faulty circuit will produce a 0. What about C0? Okay. Somebody is claiming that C is stuck at 0. If you can show that C can become 1, we are done. And there are three possibilities, we can put 0 1 or 1 0 or 1 1. Either of these will work. I am sorry, 1 0 or 0 0. If you put either of these three, the output will become 1, a faulty circuit will produce a 0. Okay. C1, a faulty circuit will produce a 1, 1 1 will produce a 0. Okay. So, this is a table that shows, okay, all the test vectors. So, we will need 1 1, that is a required test. 0 1 is required, 1 0 is required. 0 0 may not be required. If I apply 0 1 or 1 0, that is good enough. So, we need 3 vectors to test a 2 input NAND gate. Okay. So, no need to apply 0 0. Okay, it is already taken care of. So, 0 1 already covers. Okay. We say 1 1 covers A 0, 1 1 covers B 0, 0 1 covers 0 A 1, 1 0 covers B 1. Okay. So, we could write it like this. So, 0 0 0 1 1 0 1 1, these are the test vectors. 0 1 is required because it will cover A 1, 1 0 is required because it will cover B 1, C 0 is also covered by one of these guys. So, C 0 is also covered by this. One is required to cover A 0, B 0 and C 1. So, we have covered A 0, A 1, B 0, B 1, C 0, C 1. Okay. We have covered all the faults. Okay. This was not required. Okay. So, as an exercise, repeat this same exercise, repeat this for a 2 input NOR. Okay. Please construct a table like this, right, and tell me what inputs, what test vectors are sufficient to cover all single stuck-at faults, okay, for a 2 input NOR gate. So, this is an exercise for you. So, please do it. Okay. All right.